exercise 7.1 from the chapter Coordinate Geometry. So in the first question, they're asking us to find the coordinates of the point which divides the join of -1,7 and 4,-3 in the ratio 2:3. So we're going to assume that the point -1,7 as A and 4,-3 as B. We need to find a coordinate which lies between the points A and B, which is divided in the ratio of 2:3. So we know that the section formula states that mx2 plus nx1 by m plus n, comma my2 plus ny1 by m plus n gives the coordinates in which between 2 points, which is divided in a particular ratio m:n. So we're going to substitute the values that they've been given in order to find the coordinates. So here we can say that -1,7, we can take that as x1 and y1, and 4,3 we can take that as x2 and y2, and the ratio 2:3 we can take 2 as m and 3 as n. So substituting the values in the given formula, we'll be able to find the coordinates of C. So mx2 would be 2 times 4 plus nx1 would be 3 times -1 by m plus n would be 5, comma my2 would be 2 times -3 plus ny1 would be 3 times 7 by 5. So 4 2s are 8. 3 times -1 is -3 by 5. And 2 times -3 is -6. And 3 7s are 21. So plus 21 by 5. We know that 8 minus 3 is 5. So 5 by 5. And 26 minus 6 plus 21 would give us 15 by 5. So 5 divided by 5 will give us 1, and 15 divided by 5 will give us 3. So the required coordinates of C would be 1,3. In the second question, they're asking us to find the coordinates of the points of trisection of line segment joining 4,-1 and -2, -3. So they're asking us to find a point of a trisection. We know that in a trisection it divides a line into 3 segments. So we're going to take 2 points on the line segment AB, in which A is 4, -1 and B is -2, -3, such that the 2 points P and Q divide the line A and B in 3 segments. Three segments. So we're going to take the values of each segment to be 1 in order to find the ratio. So the ratio of P dividing A and B would be 1, and since there are 2 segments here, 2 sections here, this would equal to 2. So the ratio of P dividing A and B would be 1:2. And similarly, in point Q, the point Q divides AB in ratio 2:1. So they're asking us to find the coordinates of P and Q. So we're going to do that separately. So first we're going to find the coordinates of P, and then we're going to find the coordinates of Q. And they've given the ratio, and we need to find the coordinates. So using the section formula, we're going to take this as x1, this is y1, this as x2, and this as y2. In the first case, we're going to take 1 as m and 2 as n. So substituting the values in the section formula, we would get m, which is 1 times x2, which is -2, plus n, which is 2 times x1, which is 4, by m plus n, which is 3, comma m, which is 1 times y2, plus n, which is 2 times y1, which is negative 1, over 3. So 1 times negative 2 is negative 2, 4 2s are 8, by 3, comma, negative 3, minus 2, over 3. So 8 minus 2 would give us 6 by 3, 6 by 3 is 2, and negative 3 minus negative 2 would give us negative 5 over 3. So the coordinates of P would be 2 comma negative 5 over 3. So next we need to find the coordinates of Q. So we're going to take 2 as m and 1 as n, and the values of x1, y1, x2, and y2 will remain the same. So substituting that in the section formula, we would get m, which is 2 times negative 2 plus 1 times 4 over 3, and 2 times negative 3 plus 1 times negative 1 by 3. So 2 times negative 2 would give us negative 4 plus 4 by 3, and negative 6 minus 1 by 3. Negative 4 plus 4 will give us 0 by 3, and negative 6 minus 1 will give us negative 7 by 3, and we know that 0 divided by any number will equal to 0. So the coordinates of Q would be 0 comma negative 7 over 3. In the third question, they've given that to conduct sports day activities in your rectangular shaped school ground ABCD, lines have been drawn with chalk powder at a distance of 1 meter each. 100 flower pots have been placed at a distance of 1 meter from each other along AD, as shown in figure 7.12. Niharika runs 1/4 the distance of AD on the second line and posts a green flag. Preet runs 1/5 of the distance AD on the 8th line and posts a red flag. What is the distance between both the flags if Rashmi has to post a blue flag exactly halfway between the line segment joining the two flags? Where should she post her flag? So they've given that Niharika runs 1/4 of the total distance, which is 100. So in order to find the place where she stopped, as in 1/4 of the total distance, we have to multiply 1 by 4 times the total distance, which is 100. So when we multiply that, you'll get 25 meters. So she runs 25 meters on the line, which is 100 meters long. And they've said that she runs on the second line. So in order to find the coordinates, we take the second line to be the x-axis and the distance she ran to be the y-axis. So the coordinates of the green flag would be 2 comma 25. And the red flag, which is placed by Preet, is at 1/5 of the total distance, which is 100. So when you multiply 1/5 times 100, you will get 20. So he runs 20 meters on the 8th line. We're taking the 8th line as the x-axis and the distance he ran, which is 20 meters, as the y-axis. So the coordinates of the red flag would be 8 comma 20. They're asking us to find the distance between these 2 points and the midpoint of these 2 points. So first, in order to find the distance, we use the distance formula, which is x2, we're going to take as 8. So x2 minus x1, the whole squared, plus y2, which is 20, minus y1, which is 25, the whole squared, which will give us the distance of the points. Let's take the point where the green flag is placed as G and the point where the red flag is placed as R. So the distance between GR would be 8 minus 2 is 6 squared, and 20 minus 5 is negative 5 squared, and 6 squared is 36, and negative 5 squared is 25. So 36 plus 25 will give us root 61 meters, which is the distance between the 2 points. Now we need to find the midpoint between the 2 points, we know that in order to find the midpoint, it's basically x2 plus x1 by 2, comma y2 plus y1 by 2. So we don't necessarily need to know the ratio because the ratio is 1:1. So in order to find the midpoint of these 2 points would be 8 plus 2 by 2, comma 20 plus 25 by 2. So 8 plus 2 would give us 10 by 2, and 20 plus 25 would give us 45 by 2, and 10 divided by 2 is 5, and 45 divided by 2 is 22.5. So the midpoint between these 2 points would be on the 5th line at a distance of 22.5 meters. In the fourth question, they're asking us to find the ratio in which the line segment joining the points -3, 10 and 6, -8 is divided by the point -6, -1, 6. So we're going to take the point -3, 10 as point A, and the point 6, -8 as B, and it is divided by the coordinate -1, 6, which we're going to take as C. They're asking us to find the ratio in which the point C divides the line AB. So since the ratio is unknown, whenever the ratio is unknown and they're asking us to find the ratio, we're going to assume that the ratio to be x:1, k:1, where k is m and 1 is n. So we need to find the value of k. So we're going to substitute the given values in the section formula, and we're going to take this as x1, y1, x2, and y2. And they've given us the coordinates, and we just need to find the ratio. So we can say that -1, 6 is equal to m times x2, which is 6, plus n times x1, which is -3, by k plus 1, comma k times y2, which is -8, plus 1 times 10 by k plus 1. And we're going to simplify this further. So we'll get 6k minus 3 by k plus 1, comma minus 8k plus 10 by k plus 1. And since it is -1, 6, which is equal to 6k minus 3 by k plus 1, comma 8 minus 8k plus 10 by k plus 1, we can say that -1 is equal to 6k minus 3 by k plus 1, or 6 is equal to -8k plus 10 by k plus 1. So we can equate either one of these situations in order to find the value of k. So for example, in this scenario, we'll just take the first case where -1 is equal to 6k minus 3 by k plus 1. So we need to isolate the k, so we're going to cross multiply. So we're going to bring k plus 1 in the denominator over to the numerator on the left hand side. So you'll get -1 times k plus 1, which is equal to 6k minus 3. So you'll get -k minus 1, which is equal to 6k minus 3. We're going to bring 6k over to this side, so you'll get -k minus 6k, which is equal to -3 plus 1. So -k minus 6k would give us -7k, and minus 3 plus 1 would give us -2. So k is equal to -2 over -7, and both the minus signs will get cancelled, so the ratio would be 2:7. So when we equate 6 is equal to -8k plus 10 by k plus 1, we'll get the same answer as 2:7. So 2:7 is the ratio. In the sixth question, they're asking us to find the ratio in which the line segment joining A, 1, -5 and B, -4, 5 is divided by the x-axis. And we also need to find the coordinates of the points of division. So since they've said that the point P divides A and B on the x-axis, If a point is on the x-axis, that means its y-coordinate will always be 0. So we need to find the value of x as well as the ratio in which the point P divides A and B. So using the section formula, we can say that x comma 0 is equal to m, which is k, times x2, which is negative 4, plus 1, which is n, times x1, which is 1, over k plus 1, and k times k, which is m, times y2, which is 5, plus n, which is 1, times y1, which is negative 5, over k plus 1. So we need to find both the values of x and k. So we will notice that in the first situation, where if we take x is equal to k times minus 4 plus 1 by k plus 1, we will have two variables and we will not be able to find the solution. So instead, we're going to take 0 is equal to 5k minus 5 by k plus 1, so we can find the value of k, and once we find the value of k, we can find the value of x. So we're going to say that 0 is equal to 5k minus 5 by k plus 1. When k plus 1 goes to the other side, 0 times k plus 1 will equal 0. So we can say that 5k minus 5 is equal to 0. And when we bring 5 to the other side, it'll become positive 5. So k will equal 1. So that means P is the midpoint of points A and B. So the ratio would be 1:1. So now we're going to substitute the value of the ratio in the section formula in order to find the coordinates of P. So using the section formula, we can say, since this is the midpoint, we can say that minus 4 plus 1 by 2, comma 5 minus 5 by 2, which is equal to x comma 0. And 1 minus 4 by 2 will give us negative 3 over 2, and 5 minus 5 is 0 by 2, which is equal to x comma 0. And the value of x will equal negative 3 comma 2, and the coordinates of the point x P would be negative 3 by 2 comma 0. In the sixth question, they've given that if points 1, 2, 4, y, x, 6, and 3, 5 are the vertices of a parallelogram in order, we need to find x and y. Since they've given that the given points, which we're going to assume as A, B, and C, A, B, C, and D, are points of a parallelogram, and we need to find x and y, we know that the vertices, the diagonals of the vertices of a parallelogram bisect each other. That means the midpoint of two vertices are equal. So the midpoint of A and C is equal to the midpoint of B and D because the vertices of because the diagonals of a parallelogram bisect each other. So since the midpoint of AC is x plus 1 by 2, comma 6 plus 2 by 2, which is equal to the midpoint of B and D, which is 4 plus 3 by 2, comma y plus 5 by 2, we need to find the value of x and y. So we can say that x plus 1 by 2, which is equal to 7 by 2, and 6 plus 2 by 2, which is 8 by 2, is equal to y plus 5 by 2. We need to find the values of x and y. So by cross multiplication, in the first case, we'll get 2x plus 2 is equal to 14, and here we'll get 16 is equal to 2y plus 10. Isolating the x, we'll get 2x is equal to 12, and 2y is equal to 6. X would be equal to 6, and y would be equal to 3. So the values of x is 6, and the value of y is 3. In the seventh question, they're asking us, we need to find the coordinates of point A, where AB is the diameter of a circle whose center is 2, negative 3, and B, which is the end point of the diameter, is 1, 4. So we need to find the values of x and y. So they're given that AB is the diameter, and if the midpoint of AB is 2, negative 3, we know that the radius of the circle is 2, negative 3. We need to find the value of x, y. So the midpoint of x, y and 1, 4 is 2, 3. So we can say that 2, negative 3 is equal to the midpoint of 1 plus x by 2, 4 plus y by 2. So we can say that 2 is equal to 1 plus x by 2 and minus 3 is equal to 4 plus y by 2. So we need to find the value of x. So 4 is equal to 1 plus x and x is equal to 3. And negative 6 is equal to 4 plus y and y is equal to negative 10. So the coordinates of A would be 3, negative 10. In the 8th question, they've said that if A and B are points negative 2, negative 2 and 2, negative 4 respectively, we need to find the coordinates of P such that AP is equal to 3/7 of AB. So they've said that AP is 3/7 of AB. So that means that AB, the entire thing, is equal to 7 units, and AP AP equals a third of the 7th, which is AB. So the whole value of AB would be 7, and AP occupies 3 units of the entirety of AB. So that means the value of PB would be 7 minus 3, which would give us 4. So the ratio in which P divides AB is 3:4, and we need to find the coordinates x, y. So x, y would be equal to 3 times 2 plus 4 times negative 2 over 7, 3 times negative 4 plus 4 times negative 2 over 7. And x, y is equal to 6 minus 8 by 7 and minus 12 minus 8 by 7, and x is equal to negative 2 by 7 and y is equal to negative 20 by 7. So the value of x and y are negative 2, 7 and negative 20 by 7 respectively. So the coordinates of P would equal negative 2, negative 2 over 7, negative 20 over 7. Next, we're going to find the coordinates of Q. So x, y would be equal to 0 plus 2 over 2, 5 plus 8 over 2, which would equal 1, 13 by 2, which is the coordinates of Q. Next, we need to find the coordinates of R. So the coordinates of R, which is x, y, is equal to... In the 9th question, they're asking us to find the coordinates of the points which divide the line segment joining A, which is negative 2, 2, and B, which is 2, 8, into 4 equal parts. So since it's divided into 4 equal parts, we can assume that it is a trisection, and since they've already mentioned that all of the sections are equal, we can say that the ratio of P would be 1:3. Q would be the midpoint, so 2:2, which would equal 1:1, and R would be 3:1. We need to find the coordinates of P, Q, and R. So first, in the first case, we're going to find the coordinates of P. So we can say that x, y is equal to 1 times 2 plus 3 times negative 2 over 4, 1 times 8 plus 3 times 2 over 4. So x, y is equal to 2 minus 6 by 4, 8 plus 6 by 4, So x comma y is equal to -1 and 14 by 4, which is 7 by 2. Next, we need to find the coordinates of q, and q is the midpoint, so x comma y is equal to 2 plus -2 over 2 comma 8 plus 2 by 2, which will give us 0 comma 5. And next we need to find the coordinates of r. So x comma y is equal to 3 times 2 plus 1 times -2 over 4 comma 3 times 8 plus 1 times 2 over 4. So x comma y is equal to 6 minus 2 over 4 and 24 plus 2 over 4. So 6 minus 2 is 4 by 4, which is 1, and 24 plus 2 give us 26 over 4, which is 13 by 2. So the coordinates of r is 1 comma 13 by 2. The coordinates of q is 0 comma 5, and the coordinates of p is -1 comma 7 by 2. In the 10th question, they're asking us to find the area of a rhombus with its vertices 3, 0, 4, 5, -1, 4, and -2, -2, taken in order. And we know that the area of a rhombus is 1 by 2 times the product of its diagonals. So in order to find the area of the rhombus, we need to find the length of both of its diagonals. So we need to find the distance between A and C and B and D. And the product of this times 1 by 2 will give us the area. So first we're going to find the distance of AC. So the distance of AC would be 3 plus 1 squared plus 0 minus 4 squared. So AC would be equal to root of 16 plus 16, which is equal to root 32, which can also be written as 4 root 2. And secondly, the distance of BD would be 4 plus 2 squared plus 5 plus 1 squared, which is equal to 36 plus 36, which can be written as 6 root 2. So the area of the rhombus would be half times 4 root 2 times 6 root 2. So it would be root 1 by 2 times 4 root 2 times 6 root 2, and 2 and 4 would get cancelled, so you'll be left with 2 root 2 times 6 root 2. So 6 2's are 12, and root 2 into root 2 would give us 2. So 2 times 12 will give us 24. So the area of the rhombus would be 24 square units.